The solar energy is utilized or is used in the portable electronic devices as a power supply sources, and it is used in irrigation by using solar pumps, domestic water supplies, etc. The raw material used in the construction of solar cell is silicon, which is abundantly available, but the purification of this silicon requires a high cost. No emission, no combustion or radioactive residues for disposal. And there is no moving part and wear and tear. Quick installation can be integrated into a new or existing building structure. High public acceptance and excellent safety record. And even the solar cell can be integrated to a new or existing building. So these are the main or the advantage of using solar cell. And again, we can face some disadvantage of solar cell. Low density energy can produce only daytime. High installation cost, quick installation, but high installation cost generates only DC current. They require energy storage device. Battery requires maintenance and replacement from time to time. These are the main disadvantages observed. Simply we call it as a PV cell, solar cell or photovoltaic cell, PV cell. It's also called as a PV cell or photovoltaic cell. And this photovoltaic cell is also considered or called it as semiconducting diode. Okay, it's called as a semiconducting diode, solar cell or PV cell or semiconducting diode. Okay. Here we'll take PN, create a PN junction. I'll just give a rough diagram, pictorial representation of a typical PV cell, one PV cell. First, P and N type of semiconductor. Okay. So I'll just show the upper part of this semiconductor, or in other words, photovoltaic cell. So this is just outer part. See here, it consists of usually a polycrystalline silicon wafers made up of, or it is usually made by wire sawing block cast technique. One method, in that method, we'll take a polycrystalline silicon wafers, okay, and that wafers are etched to remove saw damage. During this process, there may be a silicon wafers will take, okay, it's not doped with the P or N like component. So, but it contains some damages. To remove that damages, it is usually etched by a suitable agent. That is, just it is washed with a suitable agent. Okay. So here we'll take a silicon wafers. This is a polycrystalline silicon wafers. These things is a polycrystalline silicon wafers. Okay. The wafers are usually p-doped by a surface diffusion process. N dopant is performed from the on the front side of the wafer. That means we'll take a PN or we'll create a PN junction diode. Okay. See, the bottom layer is P doped. That is what we call it as a P-typed semiconductor. Okay. So from the front side of the component or the wafer, silicon wafer is doped with N type of dopant. Okay, that is performed on the front side. That means it is a N type semiconductor. Okay, the base is a P type semiconductor. Over that, a N type semiconductors are introduced. That is, a typical photovoltaic cell is composed of thin wafers of or a slice consisting of a thin layer of phosphorus doped, that is N-type, phosphorus doped N-type semiconductor on the top of the boron doped P-type semiconductor. That is PN junction is created. This portion, this things what we called it as a PN junction. Thereby we can able to create a PN junction. This is a P dope, phosphorus doped. Here it is a boron doped component are taken. Okay. So this is the first things what we need to construct a photovoltaic cell. A polycrystalline silicon wafer. Usually it is produced by wire sawing block cast technique method. The wafers are etched to remove the damages. Then the wafers are usually p-doped by the surface diffusion process, and that is placed at the bottom of the cell. Then by the surface diffusion process of N-type dopant is performed on the front side of the wafer. That is, the one silicon wafer is taken, it is on the front side it is N-type and the back side it is P-type. Okay, the same wafer, on that we'll observe the two dopant components. Okay, performed on the front side of the wafer, so that we can able to create a PN junction. Then over this slice or a silicon doped silicon or a PN junction, a anti-reflection coating of silicon nitride or titanium dioxide is then applied by plasma enhanced chemical vapor deposition techniques. That is, here what we observed in this area, we usually perform or introduce a anti-reflection component. Okay, this is a anti-reflection components are introduced. Sorry, this area is covered by means of anti-reflection coating. Okay, this anti-reflective layer. Okay. So, an anti-reflective coating of silicon nitride. This may be, for this we may use silicon nitride or titanium dioxide is then applied by plasma technique over the silicon PN junction diode by chemical vapor plasma technique. So why we are doing this one? Usually which increases the amount of light transmitted into the semiconductor, which usually help to improve or increase the amount of light energy is transmitted to the PN junction. Here the sunlight enter this layer or this layer, so a sunlight enter, and because of this presence of the anti-reflective layer which enhance the transmittance of sunlight to a PN junction diode or a semiconductor. Then a metallic grid forms a electrical contact to the diode and allows the light to falls on the semiconductor between the grid lines. So here this area is a N type, whereas this area is a P type component. Okay. And here it creates a PN junction because of lifting of electrons and holes. The migration of electron take place and charge is developed. So, able to get light energy. This is a negative, this one is a positive. Okay. So the back side is coated with contact is made by means of a metal. Okay. And this one is a N layer, P layer. Okay. A creation of PN junction is observed. A metallic grid, this is a metallic grid, forms a chemical contact, or a metallic grid forms electrical, not chemical, electrical contact of the diode and allows the light to fall on the semiconductor between the grid lines. Okay. Here, this is a front portion, front view, or the front contact, or you can take it the front contact here. Okay. Front contact. Then the other electrical contact is made using metallic layer back side of the solar cell. That means there are two, positive and negative. That is one. This is a negative, so we'll take a front side, front contact, and this one is a back contact. Okay. Semiconductor usually have the capacity to absorb light energy. When a light energy falls on this layer, so it can able to absorb light energy. And to deliver a portion of the energy of the absorbed photon to carry electrical current, that is electrons and holes are created. When the these PN junction diode or a PN layers, they absorbs the electrical or the light energy, can able to create the electrons, they can able to lift the electrons and the holes. When a light energy falls on the PN junction diode, when it falls on the PN junction diode, electrons are and holes are generated, and by the absorption of the radiation from the light. Usually electrons or holes are created. If the electrons are present in the P-type semiconductor, they lift it to N-type semiconductor. They try to move to N-type semiconductor. And the holes which presents, they try to deposit or move to opposite direction or its original layer. Clear? So the lifting of this component takes place when a light radiation falls on the PN junction diode. The electrons and holes are generated by the absorption of radiation from the light. The electrons usually drifted and collected at the N-type semiconductor. From here, that's actually in the border, if it is present, they are collected. All negative charges are collected in the N-type semiconductor, and holes are drifted towards the P-type semiconductor. As a result, an electrical double layer is developed. When these ends are electrically charged, these are completely negative charge it becomes, and this layer is completely positive charge. So as a result, so these ends are electrically connected because of separation of charges. When these ends are electrically connected through a conductor, there is a flow of current between the two ends through an external circuit. As a result, here it is loaded with the electron, and these electrons are moved to an external circuit, and whereas in the in the p-type semiconductor, holes are created. So that's why the less number of electrons, they should move from n-type to p-type semiconductor through an external circuit. As a result, during this course, a photoelectric current is developed. Usually, in the photovoltaic cell, we can observe an open circuit volt of 0.5 to zero point 0.6 electron volt potential. And again, the current output is much that depends upon the efficiency, size, and proportional efficiency as well as size of the photovoltaic cell, as well as it is proportional to the intensity of sunlight. Okay, so these are things, that is the construction. When a light radiation falls on the PN junction diode, the electrons and holes are generated due by the absorption of light radiation from the solar energy. At that time, the electrons they completely drifted and collected at N-type semiconductor, whereas holes are collected at the P-type semiconductor. When these two ends are connected through conductor, there is a flow of current between the two ends through external circuit, which is termed as photoelectric current. Okay, so this is about the construction and working of photovoltaic cell. I'll repeat this one. The photovoltaic cell is an energy conversion cell which can able to convert solar energy into electrical energy. That is solar, the light energy from the sunlight into electrical energy. A typical photovoltaic cell composed of thin wafer or slice consisting of thin layer of phosphorus doped silicon on the top of boron doped silicon. Phosphorus, that is N layer, is on the top layer and the P layer is the bottom layer. That is, it consists of polycrystalline silicon wafer made up of the method what we called it as a wire. The method what we called it as a wire. If you want, you can search it in net. Sewing block cast technique. By this technique, uh, they are made, or on the same wafer P and N junction components are introduced. That is, then these wafers are etched to remove all damages. Then the wafer is used, usually P doped. First it is doped with the P by the surface diffusion process of then over the front side of the wafer, n-type dopant is fixed, is performed on the front side of the wafer, so that a PN junction is formed. This is a PN junction is formed, and over this wafer, okay, a anti-reflective coatings are introduced. That anti-reflective coatings usually consists of a silicon nitride or titanium dioxide coating is introduced. It is usually applied by a method called plasma enhanced chemical vapor deposition vapor deposition. By this technique, it is introduced. So usually it is introduced in order to enhance the amount of light transmitted into the semiconductor. So most of the light gets absorbed by the semiconducting component. Then above layer, a metallic grid forms electrical contact of the diode and allows the light to fall on the here. The metallic grids are introduced, and that metallic grid allows the light to fall on the semiconductor diode between the grid lines here. Then the other electrical contact, that is backside, using a metallic layer on the backside of the solar cell. That means a portion of front side and the back side is metallic coated in order to make an electrical contact. And the semiconductor have the capacity to absorb light energy and to deliver a portion of energy of the absorbed photons that to carry electrical current. Electrons as and holes are in the beginning created. When a light energy, when the sunlight is falls on the radiation falls on the PN junction diodes, electrons and holes are created. Electrons and holes are created and generated by the absorption of the radiation of light from the sunlight. Then the electrons are drifted. If any electron is present, they are drifted at the N type end, and the holes are drifted towards the P type end. When these ends are electrically connected by means of a conductor or a metal, there is a flow of current between the two ends to an external circuit, and as a result, a photoelectric current is generated. It can develop a potential of 0.5 to 6 volt, but the potential depends upon the size and efficiency of the PV cell, as well as it depends upon the intensity of the light introduced. This quantity of light we can get by a one PV cell. We can use a PV cell like array or a module. So PV module, that is what we call it as a PV module. The PV module is nothing but the array, like it's one by one photovoltaic cells are fixed. A number of solar cells are electrically connected. This is considered as a solar cell. So, a number of solar cells are electrically connected to each other and mounted on a support. That is called PV module. Okay. And the next thing is we can create a panel. The panel is nothing but by introducing a series of modules. Okay? A series of modules are connected to get a photovoltaic panel. So like this. So these are one solar cell. So I'll introduce a large number of solar cells or modules, 3-4 modules, an array of modules connected in a series or parallel. Okay. Then further, in order to generate a very high potential, we can put these modules uh, in a series or parallel way. So thereby we can able to get array, photovoltaic array, one array here, the other array, like a different large number of photovoltaic arrays are interconnected. So thereby we can able to get a potential. Okay, we can introduce 3, 4. There are many layers. You may be observed in the PV cell, photovoltaic cell. So there are large number of modules uh, are connected in series or parallel to get a complete power generation unit. Large number of photovoltaic modules or panels are connected to get a complete power generation unit. Okay. So PV module means it consists of large number of solar cells electrically connected to each other, and it is mounted in one support. Panel is these modules are connected either parallel or in a series manner to get a high efficiency current. Then further, in order to increase the output, will create a photovoltaic array. It is a complete power generating unit, consists of large number of photovoltaic